Hello everyone. Welcome to the fourth part of Modeling, Analysis and Design of PEB structure. I am Surajit Ghosh, and in this session, I will discuss how we can create the bracing members, assign standard section with proper beta angle, and member offset to Purlin and bracing members. I will use this model which we have created in the last video with tapered profile as column and rafter. If you want to know more about the modeling of this structure or structural components of a PEB which we need to consider for analysis and design, you can check my previous video. Let's start with the bracing member. In this structure, 1st, 5th and 9th pay are braced, and X-type bracings are used. We can also add bracing to other panels like 2, 5 and 8. Inclusion of the bracing member increases the lateral stability of the panel as well as the overall structure. But that does not mean we should brace all the panels. How the bracing member increase the lateral stiffness and which panels are most suitable for bracing, that I will cover in another video. To add a bracing, select the Add Beam cursor and click on the corner nodes to generate one member of the cross bracing. For side panel, single bracing is provided for the entire height, and for roof, bracing members are provided considering 2 Purlin distance. Next, we need to repeat this step once again from the support node to create another member of the cross bracing. For any PEB structure, this bracing arrangement is commonly used and more economic, but that does not mean we cannot use other arrangements. For example, there are multiple types of bracing used in the industry like V or inverted V, diagonal, X, K or eccentric bracing. Each type has its own advantage, and selection of bracing type depends on several factors including the geometry, purpose, load intensity and load path. Like for a high-rise building in high seismic zone, we can use inverted V-type fluid viscous dampers to minimize the lateral movement of the structure due to seismic activity. If you want to know more about this topic, let me know in the comments. Back to the PEB structure. As the geometry and arrangement of the bracing is same for the other panels, we can use the copy-paste option to add bracing in the 5th and 9th panel. And for this, first we need to select all the bracing members. You know, it is not that easy to select these members from the GUI. We can select a proper view. Still, it will take some time to select the members one by one. Also, unwanted members might be selected in this process. There is an easier way. We can select all these members from the geometry, beam table. These members don't have any property. So, from the beam table, we can easily select last few members with no property reference number. See, all these members are now selected, and we can easily use copy and paste option. In the paste window, there are multiple options to specify the final location, like we can specify the distance in the z-axis as 24 meter for the 5th panel. But I normally prefer to use the reference point and manually select the node in the GUI. For this, first we need to check the reference point location. As you can see, extreme lower corner of the bracing is selected as the reference node. We can further edit this. Blue dot indicates the selected reference point. For this model, I want to use this point. Next, we can simply select the corresponding node of the 5th panel. See, Z value is automatically updated by the program. X bracing for the 5th panel is now added, and using the same cursor, we need to paste it once more in the 9th panel with Z value as 48 meter. This completes the bracing member generation without any property. Next, we need to assign section to the Purlin and bracing member, which we can reconfirm from the missing property option. Normally for Purlin, either a channel, tube, Z-Purlin or sigma sections are used. Do you know purlins are the most important member of the secondary frame? These members not only support the seat and provide additional stiffness in between the rafters, but also increase the lateral stability of the entire structure by connecting all the main frame members together. It is very important to assign proper section to the purlin, and in this model, I will use a hot rolled channel section ISMC 250. Later, I will also discuss how we can add and assign a custom Z-Purlin section to these members. For bracing, I will use a pipe or CHS section from the Indian section library. Once these sections are added to the property table, we can select each section, select the members using any suitable approach, like we can use the beam parallel to the Z-axis option to select all the purlin members, and assign the channel section. For bracing member, use members with missing property option to select all this member. I have also included this option in the quick access toolbar, and assign the pipe section. With this, the structure geometry and section assignment are now complete. There are several other structural components which we need to model, like the crane girder arrangement, which I will discuss later. Though this structure seems fine, there are two things which we need to adjust. First one is the alignment of the roof purlin. Check the rendering view. These purlins are connected at the CG of the rafter, but in real structure, these members are connected at the top flange of the rafter, right? To adjust this, we need to assign proper offset value. But there is one problem. In STAAD for analysis, we normally create the stick model, and when a section is assigned to any member, by default that section is placed by the geometric centroid. As you can notice here, for different types of section, program calculates the centroid distance and accordingly place the section. For doubly symmetric I section, it is located within the web, and when we assign a variable depth tapered section to the rafter, it is placed along this line. The purlin member is connected to this rafter centroid line, and when a channel section is assigned to the purlin, it is also placed by the centroid. And if we look at this rafter purlin joint, we can easily notice how these sections are connected. This placement is normal and does not have any significant effect on the analysis results. But if we really want to adjust the section arrangement, then we need to move one member by specifying an offset value. The amount of offset is calculated from the section dimension, and program shifts the section in the specified direction by forming a rigid link between the original location and the final location. In structural point of view, this member is now converted into a frame which generates an additional moment, and this moment depends on the offset value. More offset means more generated moment, which is not good. I will not cover the technical details of member offset in this video. It will be covered later. To change the cross-section position, we need to move the purlin section in this direction, which is the local Y direction. We can switch on the local axis orientation using Shift plus O. Red color indicates the local Y axis, whereas green indicates the local Z. So for the purlin, we need to specify an offset in the local Y axis. To calculate the offset value, we need two information: dimension or centroid distance of the rafter and purlin section. We know that the centroid distance of a channel is d by 2, so it is 125 mm. For rafter, as we have assigned a tapered section, we need the exact depth at the purlin location. How can we get this information? Say we want to assign an offset to this purlin member, so we need the depth of tapered section at this junction, which is either the end depth of R5 or start depth of R6. If we open the property details of any of this section, we can notice that the depth of I section at this junction is 567 mm. That means first we need to move the channel in the local y direction with 283 mm, which is the centroid distance of the I section. Then we need to move it further by 125 mm so that the channel bottom flange sits on the rafter top flange. Total offset value at this location is 408 mm. Now we can simply go to specifications, beam, offset, select the direction as local and specify 408 mm in the y-axis. We need to add this twice for start and end of the member. Finally, assign this offset to all the purlin in this line. Check the rendering view. This channel section is now moved upwards and sits on top of the rafter. One major problem. We need to repeat this step again and again for all the purlins. For uniform depth rafter section, offset value of all the purlins remains same. But as a tapered section is assigned, we need to calculate the offset value at each purlin location. This is a time-consuming job. Do you know how we can eliminate this whole process with automation or even in the physical modeler? I will show you how in my next video. There is still one problem. This purlin is oriented in such a way that the top of the channel is parallel to the global XZ plane, and this alignment is not suitable to place the roof panel. We cannot properly connect a sloped roof panel on top of this purlin, and that's why we need to align this purlin in such a way that the top of the channel follows the roof gradient. We can change this easily with a beta angle. Once again, I will not cover the technical details of beta angle in this video, rather cover the assignment process only. Beta angle is nothing but the angle of rotation about the local x-axis, and using this value, we can rotate a section. In the technical reference manual, a detailed discussion with various standard sections has been provided. You can check that. Like the offset value, we need to specify two information: direction of rotation and angle. If we look along the local axis towards the end of the member, clockwise rotation is considered as a positive beta angle, and if we look from the opposite direction, anticlockwise rotation is considered as positive. For this purlin member, we need to rotate this section in this direction to match the slope of the roof. And as per the local axis orientation, we are viewing this section from the opposite of local x-axis. So we need to specify a positive beta angle, right? And for the purlin in the opposite side, we need to rotate the section in the clockwise direction. As the local axis orientation of the purlin is same, this time we need to specify the beta angle as negative or provide the value as 360 minus the angle. In this model, the slope of the roof is 10 degree. To assign a beta angle, go to geometry page, beta angle, specify the angle as 10 and add. Once again, specify the angle as 350, which is 360 minus 10, and add. Next, from the front view, we can select the purlin at the left side of the roof with positive beta angle, assign the first angle, then select the purlin at the opposite side of the roof and assign the second angle. Now if we check the rendering view, the channel section alignment looks fine. It follows the roof gradient. By the way, I have already assigned the offset to all these purlin members, and now all the roof purlins are placed on top of the rafter with proper alignment. Using the same concept, we can also adjust the guards. That's all. This is how we can assign a section to the purlins and align it properly. In the next video, I'll cover how we can apply gravity load on this model. See you in the next video.